Hello, and welcome to the TecQuipment YouTube live stream Q&A session that we hold every Wednesday. Today we are joined by a guest. Our guest today is Raam Shanker, and Raam is an engineer and entrepreneur who's going to be sharing some of his perspectives on sustainable design. I'm sorry, I've got a little bit of echo here as I try and battle with the mute button on my computer. So, there we go. So hopefully everybody can hear me clearly without hearing me back twice. This is Dion Knowles from TecQuipment, and I'm joined by two people today, not your regular Digital Dave. Instead of Digital Dave, we have Kyle Hatchard. Kyle, are you there?
Yes, hi Dion. Hello. Hi Ram.
Hi Kyle.
And we have Ram. Ram's there in his home office as well. Good to see you.
Hello everybody, this is Ram.
Fantastic. And we've got quite a few people watching online already with us today. We've got Jeff Hull from New York City. We've also got Shankar, we've got Niranjan, we've got Hendrayento. Fantastic to see you online. Do remember that this is a live session. You can post your questions in the chat box and we will put them to Ram or to Kyle during the live session. If you're watching it on demand, then please use the comment box and we'll come back to you at a later moment with the answer to that. So today we are talking about sustainable design practices with Ram and skill sets as well, and touching on organizational culture. And after that, we'll come back to Kyle. We'll talk about sustainable design there, and I'm going to ask him about STEAM. If you have any technical questions, then do interject, put your questions in that chat box over there. Also, before we carry on, I'll do a quick shout to Andy Ratcliffe and Bruno. Good to see you there. So less of the intro. What you're here to talk about today is we're talking to Raam Shanker. Ram, this is your time. Do tell us more about yourself.
Right, okay. I'm going to start with a little disclaimer. But if you see me sweating too much, it's not because of the pressure. It's an uncharacteristically warm day in Manchester today. Now, about myself, I'm a chartered mechanical engineer. I started life as a stress analysis engineer doing structural integrity analyses, finite element modeling, and so on and so forth. My first career transition took me to a company called David Brown Gear Systems, where I was their stress analysis engineer, and then I got promoted to lead stress analysis engineer. One of the biggest things that we did there was we designed, developed, manufactured, and prototype tested the world's biggest wind turbine gearbox. It was about 7 megawatts, about the size of this room that you see me sitting in. Following that, I moved back to Manchester to work for a company called Tata Steel, which is the Indian conglomerate in their nuclear division, where we did some interesting projects for Sellafield Limited and Rolls-Royce. The Sellafield project is going to be of particular interest for some of you because we were designing and helping manufacture what we call as gamma gates. If you're familiar with the Avengers movie franchise, if you know Hulk, Bruce Banner becomes Hulk because he gets exposed to gamma radiation. And that's what we were trying to prevent escaping when we were designing and developing the gamma gates. In 2015, I set up Equitus Engineering Limited, focusing on product development, innovation, sustainability, intelligent manufacturing, and mechanical engineering solutions. And some of the work we've done for includes clients like the European Space Agency and their supply chain via Rutherford Appleton Laboratory, Kawasaki Precision Machinery, Paul Corporation, Collinson Construction, and quite a few others. Yeah, that's pretty much what I have to say right now, I think.
Brilliant. Thank you for the introduction, Ram. And what we want to talk about is a topic that's top of your agenda at the moment is this whole idea of sustainability. And we were talking earlier about it's so important not to just think about sustainability. The end of the process is to really think about it in the design element, and design and manufacturing, kind of designing for manufacturing in a sustainable way. What's your perspective on that? Why is it so important to consider those? And what do you think academics can be doing? What kind of skills they can be giving students to make sure that they're ready to go out into the world of work and design and manufacture sustainably?
Absolutely. With regards to sustainability, I'm going to quote what Jürgen Meyer, the former chief exec of Siemens UK, said that the planet we have is not something that we've inherited from the generations before us, but it's something that we've borrowed from the generations that come after us. Therefore, it's our responsibility to look after the planet for the future generations. So taking that view on sustainability, what we need to look at is, number one, we have a population on the planet that's growing with every passing day, but the resources that we have on the planet to sustain humankind are very limited. Therefore, the question we need to ask is, how can we continue the growth of the human population and ensure the survival of humankind whilst not managing to deplete all the resources we have? Now, for example, the United Nations have got their Sustainable Development Goals, which is a set of 17 different goals which form a framework for how do we make the planet more sustainable. If you can see what I'm wearing, my t-shirt basically has the 17 sustainable goals on it. That's how passionate I am about them. The goal number 12, which is called responsible production and consumption, is particularly important from what I'm talking about today, because when we talk about responsible production and consumption, we're talking about how can we reduce the consumption of natural resources to design and manufacture the things we need without losing any of the engineering or functional integrity of the component. Like, for example, what you see here is a component we developed for the bicycle industry, which is basically 73% lighter and consumes 73% less material compared to the original design. So what I'm saying is, for the same material that the original design would have taken, we can manufacture 4 of these. And the advantage you have by bringing sustainability right at the design phase is, when you design with sustainability, you have benefits across the product life cycle and along the supply chain. When I talk about the product life cycle, design, manufacture, use, and decommission or recommission, when I talk about the sustainability along the supply chain, we're talking about less material to use, less material to process in the factories, less energy consumed, which leads to better quality of air, less cost of logistics and transportation, less carbon footprint. And all of these eventually lead to one question that we need to start with, which is, how do we make the right thing to do the easiest thing to do? I'll repeat the question. How do we make the right thing to do the easiest thing to do? Start with the question, and then you will derive all these benefits by bringing sustainability into the design practice itself.
Because there's quite a lot, I mean, to make a component like that, then you've got to have more complicated manufacturing processes, because that might be a barrier to why some organizations might not implement that initially. I guess you've got to consider the different strengths of the materials if it's not a solid block of metal. And I guess that's where it comes into making sure that students have all of these levels of understanding, but keeping in mind the sustainability and why you need to know about these things from that perspective.
If I may say so, Dion, if people have questions about the material integrity and all of that, the people at Equitus Engineering can help them overcome these concerns. That's that's one of the core of what we do as a company anyway. So
right. Okay. Great. Good stuff. Right. So that was really, really helpful to really get a perspective. If you were to give academics a couple of top tips of things that they should be, skills that they should be incorporating into students, building within students rather, what would those top tips be?
Okay, I told you the first one is, how do we make the right thing to do the easiest thing to do? Then I'll talk about a couple of other things as well. The one thing I want to talk about is building resilience in the students, in the younger generation. Now, when we say resilience, there are many paths to failure, but there are very limited paths to success. Now, today's world has become a much tougher place than it was perhaps 25, 30 years ago. With the increased complexity of the world around us, the potential for failure has increased, while the potential for being successful has kind of gone down by a similar proportion.
Yeah.
Now, the resilience is the ability to overcome these failures and discover the paths to success. It's not stubbornness. It's how do we adapt ourselves to overcome failure and continue exploring the paths to success and eventually getting there. So resilience is number one. Number two is critical thinking. I think we spoke about it earlier as well.
Yeah.
Wherein critical thinking is a skill that can also be developed, just like resilience. The idea being, when you have a situation, don't just look at the situation from your point of view. Put yourself in other people's shoes. That has two advantages. Advantage number one is your understanding of the situation and the problems become better rounded. You get a better understanding of what's happening. And number two, as a consequence of this, your ability to develop solutions or your ability to solve problems increases in exactly the same way by practicing critical thinking. An important factor to be able to do critical thinking is to have empathy for the other person or the other people, and understanding why a given situation could be problematic for other people as well. And finally, problem solving.
Yeah.
When it comes to problem solving, as the name suggests, there are two parts to it. The part one is the problem bit. Part two is the solving bit. Now, we spoke about resilience and critical thinking, both of which will help you get to the bottom of the problem. What you also need, in addition to this, is an inquisitive nature, and you need to be able to ask questions to get to the heart of the problem, to make sure you're solving the actual problem and not a downstream consequence. So when you get to the heart of the problem, then you will have your skills to help find the right solutions. And it's the same exercise again. You have resilience, you have critical thinking, and you have a consistency of approach, which will help you find the right solutions to problems.
Brilliant. Some really key points there: empathy, resilience, problem solving, critical thinking. Not technical skills, but really, really, really important skills for being a great engineer. In fact, in many, many jobs and careers, and being a well-communicative individual. Thank you, Ram. I'm going to hop over to Kyle now. Kyle, I want to talk, okay, so we've talked about some of these, I hate to call them soft skills. They get criticized for soft skills because they're not soft, they're serious skills. But I want to talk about practical, theoretical elements of engineering. We're talking about applied engineering, applying engineering to the real world. How can academics take, the whole concept of sustainable design and use, say, TecQuipment products or other products out in the world to help students keep this in mind all the time as they go through their HND or their degree, for example, or their masters or whatever? Where would you start, Kyle?
Yeah, no, great question, Dion, and I think a really great introduction from Ram. I mean, in summary, really, TecQuipment, the philosophy very much is around engineering empathy. So about creating engineering empathy with the products themselves. And I think, obviously, Ram touched on empathy in regards to an emotion, but also there's empathy in regards to the practical experience of actually handling the physical material itself. And why is that important? That's really important because you're getting feedback from that material, you're understanding how that actually behaves in the real world, because it's all well and good, simulating things and having a look at things from a sort of software perspective, but you don't really get to understand how something's actually behaving until you physically see it in front of you. And as an engineer myself, I like to have things to look at and hold and, break or make mistakes with. Do you know what I mean? That's the great bit of being an engineer, really. And I think it's really important. Obviously, the TecQuipment range really introduces students into that world and gives them that opportunity to safely explore things like material destruction from either perhaps a fatigue point of view or a tensile testing perspective, like the SM1002 benchtop tensile tester. That's a great piece of kit for looking at things like that and giving the student that feedback. But again, looking at things like sustainability and moving to the future, there's a whole variety of equipment that we can look at within that regard as well, that really opens up the student's imagination. I think, the importance of the practical really to problem solving. Ram obviously mentioned the two aspects of problem solving. You've got the problem and then you're solving it. And that's really, a practical experiment is all based around, you stood in front of a piece of equipment. Fundamentally, at first, you don't understand how that operates. You've got to understand how that system operates. And then, you work, once you understand the system, you can then go into solving the problem. And that's pretty much, the process that you will follow when you go into solving an engineering issue. just from the basics. And there's a whole variety of kit that you can look at, 450 different pieces of product actually from TecQuipment, and it's quite phenomenal. And I would urge people to take a look and see, which pieces of kit are relevant. So yeah, hopefully that gives you a bit of a summary, Dion. Does that help?
Yeah, I'm thinking, okay, if you're a mechanical engineer, you're going to be thinking about really understanding material strength. You're going to be looking at structures. You're going to be looking at engines and thermodynamics. Probably all the ranges really will have a, that deep understanding is going to help people understand and appreciate how can they design better, stronger structures. So you don't need to use as many materials, for example, that kind of consideration. But what about thinking about renewables? This obviously it's a
the hot topic. So I mean, obviously renewables and sustainability, that's a big thing, isn't it? That's something that we're all driving forward for. And as Ram touched on, in regards to the planet and our obviously responsibility to the next generations to make sure that we're creating that platform for them to be able to look after it effectively, and understanding fundamental theories in regards to perhaps solar power, where you could look at the renewable source of solar, and understanding how that then relates back into battery storage, because obviously.
Well, I'm really pleased that solar power would work really well this week, unlike last week.
Yeah, that's very true. That is so true. So yeah, 30 degrees outside, so we won't be too long, will we? No, but the TE4 from TecQuipment is a brilliant piece of equipment that allows you to understand and explore those concepts from solar power, and also battery storage as well. That's another important consideration. You've got this energy from the sun now. How do you then utilize that and convert it into a usable product for the grid? You're going to rely heavily on, either compressed air storage or, battery technology. So yeah, that's a bit of an introduction in regards to renewables, really, Dion. Hopefully that helps.
Brilliant, that's great. I'm going to talk about coastal shortly, but before we do that, I'd like to hop back over to Ram in his home office. Are you in Manchester then, Ram?
I am indeed, yes, the home of the first industrial revolution, yes.
Ah, very good, very good. Fantastic. So Ram, I want to talk now, we're talking about when the industrial revolution began, spinning right now to where we are and the skills gap. Yes, you mentioned things like critical thinking and how they're important. On your website, if I'm having a look here on your homepage, I think have you got a piece from the manufacturer that you were quoted? It's not going to appear now. It's not going to do as it's supposed to. But
I can show it on my camera if you want.
Skills gap anyway in the engineering world.
Hello, sorry.
Sorry. Forget me trying to navigate through your website. Tell me your perspective on skills in engineering and where you think academics should be focusing on helping students in addition to all this practical theory stuff.
Yeah, I mean, Kyle touched on the engineering aspects very beautifully when he said, it's all about making and breaking things and understanding how things fail. And one of my pet things to talk about is a phrase I use quite often is, especially in our field, mechanical engineering, mastery of failure is a key to success. Because if you do not understand how a given component or a material is going to fail, what are the various modes of it failing, you are never going to successfully convert that into a viable or a usable product. So mastery of failure is a key factor to success. But having said that, what should we prepare our next generation for in terms of careers in engineering? We do not know for certain what we will need in the next 5-10 years in terms of actual technical on-the-job skills. So I would say let's have a good focus on ensuring that there's a strong fundamental skill base available for them. When we talk about strong fundamental skills, we're talking about your basics, your power of reasoning, your prowess in physics, maths, and all of them. But then we also start taking them towards life skills that we touched on earlier. Things like critical thinking, resilience, mental toughness, an attitude which is basically not giving up, and the idea of being to have perseverance, because we never know. It's going to get super competitive as time progresses, the way things are. And today, if you look at engineering, where do you draw the distinction between what's mechanical, what's electrical, what's electronics, and what's computer? Take a look at the car today, for instance. It's a combination of everything, systems interacting with one another, affecting one another, influence the way things work. So rather than be specialist in a field of engineering, get your basics right and then have a generalized idea of how things work together in unison, in synchronization, and so forth. I think that's the focus. That's where the focus has to be, rather than making them specialists. Give them the basics and then make them generalists. We used to say back in the day, like, jack of all trades, master of none. Make them jack of all trades, but make them the master of one.
Right. Brilliant. Interesting perspective. Yeah. I guess there's always going to be a place. You need the specialists in the world. That's, or maybe if you have a specialist skill set, but you need to make sure that you build up this wider skill set that wraps around that core skill set to be a fully rounded graduate moving forward. Brilliant. Thank you very much for that. Kyle, I'd like to hop back over to you now. We were talking about solar while we're talking about sustainability and perhaps sustainable energy creation. We could talk about flumes and tidal energy. Could you tell me more about what TecQuipment can offer to support academics with that element of focus?
Yeah, of course. I mean, Flumes, obviously, understanding fluid hydraulics and how the fluid behaves is fundamental. But we obviously manufacture a range of flumes from the FC600 down to the FC300, the FC80. So for those of you that doesn't mean a great deal to, it's basically flow channels that are either 300 mil wide by perhaps 10 meters or 15 meters long, even 600 mil wide, running up to perhaps 20 meters in length. And what does that do? That gives academics the ability to investigate the phenomenon and the theory around, obviously, fluid flow. So things like fluid flow in a weir, the behavior of sediment transfer, this kind of thing. And why is that important? I mean, it's important in regards to sustainability, because obviously you can utilize that flow in regards to generating energy or generating electricity from that energy, particularly if you're using, perhaps, for example, the fall of the land. So I used to work quite closely with a particular organization who run a model in regards to a business where they will, if you've got a piece of land with a particular big land relief, they will implement pieces of equipment which will allow you to utilize the fluid flow from rainfall effectively and generate electricity. So yeah, no, obviously understanding fluid flow from that perspective is critical in regards to sustainability and the future of technology, really. And like Raam said, focusing on the whole overview of what is out there is essential for students and future engineers to be successful in a very diverse and hyper-competitive market. And really, obviously, then allowing them to find their niche and explore their passion, which is where you'll end up seeing a lot of innovation as a result of that, is really important. And the flumes allow you to be able to do that, because you can then extend it into research and take them even further into the investigations away from fundamentals, creating your own projects and that kind of thing. So yeah, there's some quite exciting kit out there that really helps students in that respect.
Thank you very much, Carl. That's really, really helpful. Now we're going to flip back over to Raam. Raam, I wonder if you could perhaps talk about a particular project that you've done and the different elements of perhaps mechanical engineering considerations, so we can think about perhaps the disciplines that you would have thought about, so that perhaps students who might be watching this can get a greater appreciation of how it applies in the real world. I don't know whether you've got something on your website you could point me to, or...
I could point you out to something I'm holding in my hands right now. So
okay, brilliant.
Nothing better than an actual product for people to look at, isn't it?
Yeah.
So going back to what Kyle mentioned early on about designing and making things and doing things in the real life, one of the things we do as a company is called design for manufacture. Because when we start using things like 3D modeling to do things, you can press your mouse button and pull things in and out, but that's not how things get made in real life. So what we do is something called as design for manufacture, which starts bringing in manufacturing into perspective right at the design stage, so that when components hit the shop floor, you don't have any nasty surprises. Now, last year, we were part of a project for one of the European Union organizations called Interreg Northwest Europe, where we delivered a piece of medical healthcare innovation in the form of this valve, which is used for assisted breathing. Now, what happens is when somebody is using a breathing machine to breathe and they are under anesthesia, what happens is the breathing machine has the flow rate, which is preset at X liters per minute or whatever. Now, imagine there are two extreme situations. Situation number one is the pressure in the human lungs goes down. In simple terms, it is somebody is gasping, they go, which means they want more air. In which case, the machine cannot cope because the flow rate in the machine is set. There's the other extreme situation where the pressure in the lungs goes up, which is somebody when they are coughing. In which case, the machine still cannot cope because it has to remove excess air out. So the client asked us if we could develop some kind of a valve, like a pressure relief valve, which is ISO 13485 medical grade compatible, fits in with the normal standard F15 connector is what the technical term is. We said, yeah, let's give it a go. We'll see what we can do. So we developed the entire model using 3D modeling. We use Autodesk Inventor to do the 3D modeling with a little bit of Nastran to do finite element analysis on the components, to determine the spring rates and the force on the spring. And then we use what is called as CFD Ultimate, which is computational fluid dynamics, which basically simulates fluid flow phenomena, things like aerodynamics, fluid mechanics, thermal fluids, and heat transfer and all that. We did all of that, and we developed a design. And I was invited to Stuttgart in Germany last October to present this in front of an audience of the various EU organizations. And we finally managed to 3D print the entire assembly. There are a few little bits on the inside. If you look very carefully, there's a lot of things going on, if the light is clear. So this has two channels. If you see the two holes, those are the two channels. So like I said, when the person is gasping, the valve opens one way and lets excess air in from the ambient until normal breathing is restored and the machine can take over again. Similarly, when someone is coughing, this valve opens the other way and lets excess air out, again, until the machine can take over and normal breathing is restored. So this is just a sample part that we've 3D printed, and we're hoping to do some full-scale manufacturing and distribution of this very soon. So this is a good example of where we brought in principles of 3D modeling, design for manufacture, fluid mechanics, structural mechanics, manufacturability, and using the right kind of plastic so that it's long-term sustainable as well. You don't use it and throw it away. So yeah, that's a project that we did.
Brilliant. That's fantastic. Very, very insightful. Gives a real world application so that students can really apply all those different discipline areas as they're thinking about sustainable design. Good. Okay, so Kyle, I'm going to hop back over to you now. Kyle, I was hoping that we might be able to talk slightly different now. We're going to be talking about STEAM because many people, okay, perhaps not engineers, but lay people on the street will think of STEAM as like steam engine, stuff like that. And they don't necessarily think about how prevalent, how much it's used in industry and why it's important for students to be understanding STEAM, not just to understand what happened in the past, but what's happening now and what could happen in the future. Now, if you could tell us more about that, Kyle.
Yeah, absolutely. I mean, yeah, so STEAM obviously is critical in regards to, its efficiency, its ability to be utilised as a tool in industry, but also a source of power generation. So utilising this within turbines, for example, delivers high efficiency rates. And obviously understanding those principles, like you've got there on the screen, Dion, you can see the thermal power plant, the TD1050, which actually, believe it or not, utilises a steam engine design that was utilised in the war, in the Second World War, on the front line. And it's a fantastic, very robust little steam engine with its own condensing boiler in there too. and allows obviously students to explore thermodynamic principles. You've got a calorimeter on there, you've got various data acquisition points, but really obviously introducing them into these technologies, these understanding these sort of, as you would think initially, these old technologies. However, they're very sustainable technologies for the future as well. So again, it becomes an excellent platform for understanding how you can perhaps utilize steam. You know, even if you've got that on the front line, it just shows how versatile that's been used in applications in the past. And obviously there's future applications in the future in regards to running machinery and plants and that kind of thing out in very hostile environments. So it's an excellent, obviously, opportunity to really allow a student to get their head around the thermodynamic principles that are involved in what would seem quite a complex process.
Great, thank you very much, Carl. What about the other products within that range?
Yeah, so obviously we've got the saturated steam, the Marseille boiler. So effectively you've got the same principle in the thermal power plant as well, but it introduces students into really the relationship between the pressure and temperature, and which is really, you know, a lot to do with obviously thermodynamics, work and heat transfer, entropy, and allowing them to conduct various different experiments to understand the temperature and pressure curve.
Brilliant, thank you very much. Right, I would just like to remind everybody who's watching this live, this is your opportunity to ask questions. We are going to be opening up for general questions in a moment, so do post those there. We've had one question for you, Ram, first. It's Jeff in New York, actually. Jeff particularly likes your t-shirt. Can you remind us where that logo is from? And maybe did you get it printed yourself, or did you buy it from eBay or Amazon? Can you still hear me? Okay.
Sorry, was that a question for me or
Yes,
Jeff?
it was. Do remind us, you know the logo on your t-shirt. It's from, is it from the world?
Is it for me? Sorry, Dayon.
Yes, it is, Ram. Yes,
Okay.
you and your t-shirt. It's not at all overly serious, but any question goes.
Well, this is the United Nations Sustainable Development Goals.
That's it.
So yeah, you just get the image, you get it printed, and you get the T-shirt. And I just wear this because of my commitment to the UN SDGs and the commitment of Equitus Engineering to not just align ourselves with the SDGs, but help companies align with the SDGs in a measurable manner.
Brilliant. So get yourself on the United Nations Sustainability website, grab off the image and send it to the printers. Job done, Jeff.
Job's a good one.
Okay, brilliant. Thank you, Ram. Any more questions? Do post them in the chat box right now. If you are watching this on demand, you can put your questions in the comment box as well. Now, while everybody's plucking up the courage to ask questions, I just want to remind you what we have coming up in the very near future. Over the course of the July, we will continue our live Q&A sessions. We will continue the webinars. We will break off in August. You can look forward to in July, we've got Roger Penlington from Northumbria University, and he's going to be here talking about blended learning. That takes place on the 19th of July. So if you're interested in that topic, then I'd suggest you pop that note in your diary. We've also got a few specialists from the Nottingham Trent University talking about autism. What we're doing here is we're talking about considerations for academics and fellow students, for other students that may have autism. So do join us for that. We haven't yet got a date confirmed. I'm hoping that may well be early mid-July. So watch out for those Q&A sessions, and we will have more guests joining us throughout that month as well. Webinar-wise, tomorrow, we're talking about VDAS, because that is the versatile data acquisition system that comes with many of TecQuipment's products. and it allows you to capture data, chart data, all kinds of wonderful capabilities there. And Digital Dave will be taking us through the benefits, the setup, but he'll also be doing a live demonstration from his home office with the thick cylinder apparatus of VDAS, so that you can really understand its capabilities. We'll also be discussing things like, how can this fit into a remote learning situation? How can it help with distance learning? We were talking last week with Oliver Shaw from Trafford College and how they're using VDAS, for example, to help with that distance learning and remote learning. If you're interested in that, there'll be a link below that appear at the end of your screen as this webinar closes as well. So that's pretty much it. If you have any more questions, ask them now. I'll be counting down to about 10 before we end this webinar. Ram.
Yeah, I have a question, Dion. Is that all right for Ram?
Go with your question, Kyle.
Yeah, is that okay? So, yeah, I'm curious to know, Ram, really. Obviously, you've been involved in industry quite heavily, and it would be interesting to learn from your perspective. What do you see for the future of engineering in the UK, and where do you see that moving to in regards to manufacture?
Okay, wow. Okay.
It's a big one.
Just dropped the ball on me towards the end, Kyle. That's all right. I mean, I've been giving it a bit of consideration for quite a while now, and for me, the three critical industries, if you like, is one is sustainable aviation and transport, because there is necessity to make things lightweight, electrical, and so on and so forth. Brings me to the next thing, which is electric cars and electrification.
Yeah.
And more importantly, having the right infrastructure for charging cars, because if, like me, you live around Greater Manchester, you could get stuck on the M60 in an electric car where the battery could die with no room to charge it.
Yeah.
So electric infrastructure, electric, sustainable aviation, and obviously clean energy, whether it is fusion, fission, more renewable, micro renewable, that's pretty much where I see the future is with regards to manufacturing.
No, thanks, Ram. Obviously, yeah, that's really interesting.
The one thing I want to add to that as well, Kyle, is what I normally do is, obviously there is the company website. I have my own website as well called raam.work, where there is a weekly blog I write about innovation, sustainability, engineering, people, culture, product development, and so forth. And there's a very similar theme on Equitus Engineering, focusing on organizational challenges with structural fluid mechanics and all sorts of things, which is engineering and manufacturing pertinent to the UK and to the rest of the world. So I would say take a look at that on a weekly basis for a new blog article. You'll probably hopefully get some good knowledge from it.
Yeah, no, that's fascinating. Thank you very much indeed. I mean, I'm curious because my background is manufacturing, and I spent my sort of initial years of my career in gearbox manufacturing, Halewood. I'm not too far from you, to be honest with you. And I love working with the people there. They were excellent. But the thing that's always been in the back of my mind ever since the electric vehicle, came along, was the need for gearboxes and manufacturing, and how the automotive world is going to change in future. So I was curious to understand, just your perspective on the future of the direction of manufacturing in the UK. So yeah, it was interesting.
Fair enough. Thanks, Carl. I think I'll find you and add you on LinkedIn, and we can have this chat.
Yeah.
Outside of this webinar as well. I'll do it straight away.
Okay. Awesome.
Can I also quickly say thanks to everybody who has taken the time to attend and listen to me ramble on about things, if for lack of a better phrase.
Ram, thank you so much. It's been a pleasure. It's been very insightful. And thank you for being part of this. It's been great. I have pulled up on the screen now. You can see Ram's website there, and you can see lots of interesting blog posts. So you may well want to go and check that out. In the chat box, I've also put a link to the UN Sustainable Development Goals area, so that you can check those out if you want to delve into that more, grab that image and create your own t-shirt maybe. Also, Kyle, thank you for stepping in the shoes of Digital Dave, as he prepares for the VDAS webinar tomorrow.
No, you're welcome, Dion.
You've been fantastic. We will be back tomorrow with a webinar of VDAS. We will be back next week with another guest on the Q&A live, and we will also be doing another webinar next week, and we'll be talking about physics A-level. We'll be back with Kyle, and we're also joined by Matrix. Matrix will be covering the electrical side of physics A-level, and we will be covering the mechanical side of physics rather, A-level. Okay, so thank you very much, everybody, Raam and Kyle, and everybody who's watched us live. But before we do go, I've just looked over to my screen on the right, and there is another question coming. So we will not be wrapping up quite just yet. Right, 2 questions, in fact. What role do you see artificial intelligence playing in the manufacturing sector, Raam? And that comes from Babacar.
Right, okay. So there are a number of roles artificial intelligence can play in the manufacturing sector. What I need to do before I answer this actual question is take you back to the first 3 industrial revolutions, where the recurring theme has always been machine capability versus human ingenuity coming together. It's always been machines and people. It's never been machines against people. So what will happen with artificial intelligence and computing is combining the strengths of AI, which is number crunching, storage capacity, and speed of response, combining with human ingenuity, which is the creativity and the sense of moral responsibility and sense of ethics. So what will happen is AI will take away all the mundane jobs that we do, and that will be AI. And the important decision-making jobs will be what people will do, which means our life as engineering and manufacturing professionals is going to get really, really interesting going forward. There'll be no more mundane things to do. There'll be exciting, interesting, positive things to do.
Brilliant. We've also got another question. With regard to sustainable manufacturing, a large consideration must be the waste material that is being generated. So are additive manufacturing techniques the way to go about reducing that? And also, what are all the other developments in that area? I guess he's talking about additive manufacturing.
Yeah, additive manufacturing is one way to go. The other way to go is the old school way of casting things. If you don't have a problem with many things, casting things is another way to go forward. And yeah, additive definitely looks like the future. In fact, this one we're going to start talking to a company that specializes in metal additive manufacturing to see if they can print out a couple of test prototypes for us to see how good it is when compared with simulation results. So additive is definitely there. You can also try looking at casting if there are better, more advanced casting techniques and better material properties to be gained.
Okay, fantastic. I hope that has answered all your questions. Appreciate the interaction. Appreciate everybody watching around the world. And thank you so much again, Raam, for being part of this today. If you like it, maybe put a like on the video. That's always nice to see, and maybe even share it with somebody. That would be even better. And don't forget to return to see us more again next time. Raam, thank you so much.
Thank you, Diane. Thank you, Kyle. Thanks, everybody.
Cheers, Raam.
Cheers,
guys.
And goodbye.
Bye-bye.